Okay, alright. In this tool demo, we're gonna look at the Striker mutation testing tool, which is available for JavaScript and TypeScript and all the derivatives of JavaScript, and it's also available for C# and Scala. But in this product demonstration, we're gonna look at the JavaScript only. So mutation testing pretty much takes your code that you've already compiled and uses mutation rules to introduce some faults in your program and then runs your tests on them. If your tests fail, then the mutants are killed. That's what you want, and the amount of mutants that is killed gives us a qualitative measurement of the tests that you already wrote. So on the website they have an example here with casino, and it's checking the age of the user. That's the function that does that, and the rules for mutating are generating those things, as you can see here. And here they put like some output, and if we get that output, means this mutant is killed, then we can see that they must have some test that tests to get in a user that is exactly 18. So with the original code here, he gets in, that's what the test assumes, and the mutation, he doesn't get in, so the test fails. But if the test is mutated to be only true, then he always gets in and the test doesn't fail. So that's pretty much the concept, that like depending on the test you have, some might fail and some don't, and that gives you a qualitative measurement. And depending on the things you get here, you can upgrade your tests and make them kill more mutants, which for some mutants you get might prevent a bug that might have occurred later in reality, but also like some things are like somewhat superficial. Okay, so now let's look at the demo I've built. So the demo is a tic-tac-toe game that's gonna be tested by which test's gonna be tested by a Striker mutator. And in order to get everything set up, you first install Striker mutator. You can do that globally or locally. In this case, I chose to do it locally. That's why we call the tool with npx and not you just have to put npx in front of it so it finds the tool which is installed in the modules in the bin folder. You can see there's Striker, and so when you initially set it up, you call npx Striker init, which gives you a nice dialog that you can navigate through. It gives you a bunch of choices, which generates this JSON file. You can also choose to have it generate a JavaScript file, and it pretty much generates everything except for this, which I added later in order to instruct Striker where to find my code which it should test. So other things you can specify here are like the reporters, so how the mutation test results should be reported to you. Here I chose clear text, which gives us like a command line clear text style output with a progress bar which updates while it's running. And yeah, and then choice you can make is for the test runner. You can choose from a bunch of test runners. I chose yes, there's also Karma available, and like some others that I don't know by heart, then you have to specify which package manager you're using. In this case, as you can see, I'm using Yarn, which is just the same as npm but a bit faster. And yeah, that's pretty much it for the configuration file. So the actual code for the projects is like a tic-tac-toe game that came from GitHub, and I adjusted it to be like split into files. One file is like just running the code, and the other one is like containing the functions to enable the tic-tac-toe functionality. And I'm only testing this one, which I've specified in here. So it's not using this because of the exclamation mark, and it's using all the other files in the source directory, which is in this case just this one. And yeah, so this is the output when I do run striker, when I execute this command, striker run, and it just runs the mutation tests, reports the survived mutations, which are reported in the form that's the original, and this is the modification. And then you get your score, the killed mutants, the mutants that caused some endless running loop, which is causing a timeout, then the amount of survived mutants, which are listed here, then the mutants that cause errors, which in this case 3, and yeah, some general information about the time, how long it took, and how many tests it ran. And yeah, in this case you can see my score is pretty high. That's because I wrote the tests to kill all the mutants possible. So this might be what you want. You might want to have a certain score. Like some mutants to kill are like somewhat superficial. They probably don't help you that much to have all mutants killed, but the tests I've written to kill them are like pretty natural to write. So it feels like that the tests I've written, killing all the tests specifically, are better than I would have written them without the tool, which is like pretty pretty good thing. So this one here can't be killed. So if we look at the code, I don't know, yeah, it's off by one line. I don't know why, but like it's referring to this line here, as we can see, and this line gets an equal sign introduced, and what's happens there is that it would just access an array of 3 elements, which are like those ones at the index 4, which just as we can see here results in an undefined, but this doesn't influence the functionality of this method. It's just like a bit of overhead that's unnecessary, but it's operating in the same way, and we can't really from the outside test if there would be this equal sign or not. So that's an unkillable test which we have to live with. And yeah, and all the other tests, all the other mutants that existed were killed. So we can see that if I, for example, uncomment this test, then we should get more mutants that survive. So if I call it with, it was actually the right one. So if we call that, it runs the tests, gives us a progress report, and like the errors that happen. And you can see the progress, so it shouldn't take too long. Then we're done and we get like 19 more mutants that survived. And we can see all the mutants that happened, and it's like replacing parts of the string, it's removing line break, and it's doing all sorts of funny stuff. So this test is pretty important in order to kill mutants. And yeah, that should cover the most important things for this demo. And yeah, one more thing I can think of, I also used some mocking in order to fake user input, which works also pretty well with Striker Mutator, and it works pretty well together, and it didn't give me any additional trouble to have like user interaction tested, and should play well with everything that's playing well with Jest or other test runners that you use, so shouldn't get in your way too much. And that's it.